All right, let's go. All right, first things first, all right, slope. Should not be a foreign concept, something you guys have heard quite a bit about. When we talk about slope, okay, in simple terms, we are basically talking about how steep is a line, okay? We're going to look at a lot of lines. How steep is it, okay? Is it positive? Is it negative? Is it horizontal? Is it vertical? You know, what's the steepness of that line, okay? That's primarily what we're talking about with slope, all right? And as I have listed up there as well, there's a relationship there, a relationship described by how y values change in direct relation with x values, okay? How y values change in direct relation with x values, all right? Now, I will probably assume most of you have heard rise over run. Would I be correct in that assumption? Okay, rise over run, all right? Now, just remember, rise, that top number is going to talk to us about up and down movement. Guys, that is your y movement, okay? And that's one of the tough things to remember about slope is that when we deal with slope, the y stuff is always on the top. That is the stuff you primarily deal with first, okay? So the y values are going to be on the top, but that top number talks to us about up and down. A positive number is going to give us an upward direction. A negative number will give us a downward direction, okay? The run on the bottom in that denominator, the run is going to talk to us about right and left movement, okay? Right is positive, left is negative. All right, rise over run, up and down versus right and left. Again, that relationship between y value movement up top versus x movement on the bottom, up and down versus right and left. Okay, that is that relationship, rise over run. Everybody okay with that? Should be something that we have some familiarity with. We're just going to hopefully get a good refresh on it, all right? Okay. Now, some things that we need to pay attention to, all right? Some information that oftentimes is visually available for us. We just need to kind of know what we're looking at, all right? When you look at the graph of a line, we should recognize pretty quick whether or not it's an uphill or downhill line, which then corresponds to whether or not that slope is going to be positive or negative. Picture top left, okay? That line top left there, that line is uphill from left to right, okay? And when you're trying to look at a line and determine whether or not it's uphill or downhill, guys, we are always looking at that from left to right. So top left, that is uphill from left to right, okay? That is going to be associated with a positive slope, okay? If the line is uphill, that means we should expect a slope that is positive, okay? And, you know, where does that come into play? Well, when you go calculate slope, and that's what we're going to do here in a minute, all right? If you look at a line and you look at it and say, you know what? That's an uphill line. I should expect a positive slope. But when you calculate it, I got a negative slope. Well, hopefully you catch that and you go, no, wait a minute. I should have gotten a positive slope. Why is my slope negative? Oh, I made a small careless mistake here. I've got a sign mistake. Let me fix that, okay? Guys, you should be able to know and anticipate what you should get for a lot of these types of things, all right? Bottom left, that is a downhill line from left to right. A downhill line, we should expect what kind of a slope then? A negative slope, okay? So if it's downhill, anticipate a negative slope. But again, this is information that we can get visually. We just have to know what we're looking at, okay? Now, a couple special cases, so to speak. Picture in the middle. That is a horizontal line. How steep is a horizontal line? How much steepness does a horizontal line have? Zero. The slope of a horizontal line is 0. You need to know that, okay? If we see a horizontal line, we really shouldn't have to do any calculations at all. We really don't need to do any rise and run. The slope of a horizontal line is 0, okay? Now, here's the other thing. Like, in order to get a 0 slope, that means 0 is going to be your rise number. It's going to be the top number. So if we are calculating slope, okay, and we're going to do that. If you calculate slope and you get 0 up there in that numerator for your rise number, guys, that fraction is going to be 0. You're dealing with a horizontal line, okay? So 0 over any number is going to render 0. That is a slope of 0, horizontal line, okay? Now, the last line over there on the right, that's a vertical line. How steep is a vertical line? Pardon? How steep is it? Very steep, isn't it? Very steep, okay? Straight up and down. Does anybody remember the slope of a vertical line?
No.
Good, honest answer. I like it.
Wait, is it 90?
A vertical line is so steep we cannot define it. Therefore, the slope of a vertical line is undefined. Slope is undefined. You need to know that, okay? A vertical line is so steep, we cannot define it. The slope of a vertical line is undefined. Now, what does that mean as far as calculating slope and as far as rise and run? Well, if you end up with 0 in the denominator of your fraction, which is your run number, okay? If you have a number over 0, guys, division by 0 in math is not good, okay? It makes things become undefined. So a vertical line has an undefined slope. And what that means as far as rise over run means you have 0 in the denominator, okay? This is information that we kind of need to associate together. Vertical line, undefined slope, that's 0 in the denominator. Horizontal line, slope 0, that's 0 in the numerator. Uphill line, positive slope. Downhill line, negative slope. This is all information that we should be able to acquire visually if we can make these associations. And I think that's important for you to be able to do. Okay? Any questions here?
No, sir.
Fantastic. Does anybody still need this slide? Okie dokie. All right. All right. First part of the assignment today. Okay, and I'm gonna pass you out a handout here in just a minute. Okay, once we go over this. All right. First thing we're going to do is we're going to determine the slope from the graph of a line, from a picture. Okay. And in doing that, we are going to need to use our rise over run. Okay. Guys, if they give you the picture of a line and they want you to determine slope, and it's on a nice coordinate plane like this with all the grid marks, it really should be pretty easy, okay? Because all you're going to do is count squares, all right? You need 2 points. We need 2 points to determine a line. They have defined 2 points for you here, okay? It does not matter which point you start from. You can start with the high point, work down to the low, or you can start low and work high, okay? I'm going to start right here. I'm going to start with this point here, and I'm going to work up to that point there, okay? Rise. Guys, you need to go up and down first. Remember, slope stuff is vertical stuff first, okay? If I'm going to go from this point to this point, where do I need to go, up or down? From this point here. If I'm going to go from here to here, do I need to go up or down from here first? Need to go up. How many? 1, 2, 3, 4, 5, 6. That's up 6. Up is a positive direction. Now, once I get there, where am I headed? To the left. 1, 2, 3, 4, 5, 6. That's left 6. Left is a negative direction. Guys, this is a downhill line. A downhill line, I should expect a negative slope. So my answer better be negative. If it's not, I've got a mistake someplace. Okay? Up 6, left 6. That's 6 over negative 6. What's 6 divided by negative 6? Negative 1. My slope is negative 1. Guys, we always want to reduce fractions to lowest terms, okay? Guys, with slope, we're always going to, with slope, we're never going to make it a mixed number, okay? Are there places where a decimal slope's okay? Yeah. For the most part, guys, today, leave everything fractional unless we can leave it like this. 6 divided by negative 6, negative 1. We're good with that. My slope is negative 1. Okay? Now, what if we went the other direction? Guys, again, it doesn't matter. If I went from this point, if I'm going from the high point to the low point, where would you go from here first? Would you go up or down? You'd go down. We would go down 1, 2, 3, 4, 5, 6. Down is a negative direction. Down 6. And then where would we go? To the right 6. 1, 2, 3, 4, 5, 6. Right is a positive direction. Down 6, negative 6. Right 6, positive 6. What's negative 6 divided by 6? Guys, it's still negative 1. It doesn't matter. It doesn't matter which point you start from. Okay? The slope of that line is negative 1. Okay? Really, any 2 points on that line, if you calculated the slope, should give you a negative 1. Okay? Any questions there?
No, sir.
Okay. All right, here in just a second, I'm going to pass this worksheet out. Okay? I'm going to pass this worksheet out. Let's take a look at a couple of these. Take a look at that right there. They have defined 2 points for you. I think they're clearly marked there. Okay, again, it doesn't matter which one you start with. If I start here, if I'm going to go from here to here, where would I go first? I'd go up, how many? 1. You would go up 1. That's a positive direction. Over which way? To the right 2. 1, 2. That is correct. Okay? Guys, it's an uphill line. We should expect a positive slope. Anticipate a positive result. 1/2. That's it. Our slope is 1/2. Okay? And you might go, well, what if I went the other way? What if I went the other way? What if you went down 1, left 2? A negative divided by a negative is it's still 1/2. Guys, it doesn't matter. Okay? You start with whichever point you want to start with. Okay? We're going to come out with the same result. Okay? 1/2 is fully reduced. That's it. Okay? What's the slope of that line? 0. No calculation necessary. It's a horizontal line. The slope is 0. Just come out here and put 0. Slope 0. Okay? You see a vertical line? What's the slope of a vertical line? Undefined. You write undefined. Okay? Now, I will tell you on the back, when you go to the back, now what are you not seeing on that line? Okay. What's happened here is they have not defined 2 points for you. You need to go find 2 nice points on that line. Now, a line is made up of infinitely many points, okay? For the purpose of counting these squares, though, I want some nice points. So I would look along here and I would say, you know what? That's a nice point. That's a nice point. This one looks like it could be, but it's a little bit off. Guys, you don't want points that are kind of halfway or midway, and you don't want to be dealing with, well, is that half? Is that a fourth? What is that? I want 2 points that I know are going to be right on these intersection points of these grid marks, okay? So I would probably choose those 2, and now I would count. If I go from here, 1, 2, 3, 4, 5, 6, 7, 8, that's up 8. 1, 2, 3 to the right. That's an uphill line. I should expect a positive slope. I've got a slope of 8 over 3. I can't reduce that anymore. Don't make it a mixed number. Don't make it a decimal. Leave it right there. 8/3. Okay? For every 8 units that the y value changes, the x value changes 3 units. Up 8, right 3. Up 8, right 3. Or down 8, left 3. Down 8, left 3. Okay? You could do it the same way if you went for the other point. 1, 2, 3, 4, 5, 6, 7, 8. And left 3. A negative over a negative, still a positive. Either way, you should get a positive 8/3 there. Okay? But on the back side, you need to choose 2 points. 2 nice points. Make them nice. I had some people yesterday, they were choosing points like I had somebody choosing something like this. And I was like, guys, you're not doing yourself any favors there. You're not sure if that's exactly halfway. You don't know really where that's at, okay? You want nice intersection points. You want to be able to count squares nicely. Okay? Okay, second half to the assignment, all right? We need to be able to calculate slope if we are given a couple of ordered pairs of numbers, okay? And quick refresh real quick. Remember, an ordered pair of numbers. An ordered pair of numbers is an x and a y value that describes a point on a graph, right? Every point on a coordinate plane is described by an x and y value, hence an ordered pair of numbers, okay? So please remember, when you see these ordered pairs, we are talking about x's and y's, an x and a y value, okay? Now, I do have the slope formula here for you. This would be good for you to know. I think it was on the warm-up today. Lowercase m represents slope, okay? And the way that formula is read is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. There is subtraction going on. Okay? That formula has a built-in minus sign. Okay? The 1s and 2s, those are just designations for your x's and your y's. And guys, quite honestly, those really don't make a difference. Okay? This is just the formula for slope. Okay? All that's really going on here, is that you are going to subtract the 2 y values on top, and you're going to subtract the 2 x values on the bottom. It does not matter which way you subtract. Just make sure you subtract the same way for both the y's and the x's. Okay? You can subtract right to left, great. Do them both right to left. You can subtract left to right. Do them both left to right. It doesn't matter, okay? And I'm going to illustrate that with this example right here, okay? I've got the same 2 ordered pairs. I've got the same 2 points on a line here, okay? The 0.53 and the 0.37, okay? This first time, I'm going to subtract from left to right, okay? And so plugging into this formula, There's my y values. I'm going to go 3 minus 7. I would strongly encourage you that after you write your first number, to put the minus sign right behind it. Okay? And we're going to kind of see that in my next example, but I'm just telling you, when you write your first number, I would encourage you to put the minus sign right behind it. 3 minus 7. There's my y values. On the bottom, we're going to go 5 minus 3. The 3 and the 7, those are your y values. The 5 and the 3, those are your x values. Okay? What is 3 minus 7? Negative 4. What is 5 minus 3? 5 minus 3? 2. So, we end up with negative 4 over 2. What does negative 4 over 2 reduce to? Negative 2. Slope is negative 2. Okay? If you write it negative 2 over 1, that's fine. Okay? Fractions are pretty good with slope because slope is rise over run. If you've got a top number and a bottom number, it works really well. Okay? Now, I'm going to work the same problem, except this time, I'm going to subtract the other direction. I'm going to go right to left. Okay? So over here, we're going to go 7 minus 3. There's my two y values again. And on the bottom, we're going to go 3 minus 5. It doesn't matter which way you subtract. Just do it the same for both. 7 minus 3 is 4. 3 minus 5 is negative 2. What's 4 divided by negative 2? 4 divided by negative 2 is? Negative 2. We're getting the same answer. We're getting the same answer. It doesn't matter which way you subtract as long as you subdue it the same for both. Okay?
Yep.
Any questions there?
No, sir.
Does anybody else need anything from this slide? Okay, well, let's look at another one. Now, two different ordered pairs, 2 different points. Okay? Now, be careful. Be careful with your negatives. Okay? 8, negative 3, negative 5, negative 2. Be careful with negatives. This is going to be like those negative exponents. Okay? And when we did negative exponents and we were subtracting, when we were dividing, I kept telling you guys, I said, look, when you're subtracting with negative exponents, be very careful. It's the same thing here. There's a built-in minus sign in your formula. Which way you want to subtract here? You want to go left to right or right to left? Which way you want to go? Left to right. Let's go left to right. Guys, we're going to go left to right. What are my two y values? Say again? Okay, negative 3 and negative 2. So we're going to go negative 3 minus, guys, when you write that first number, put a minus sign behind it. Negative 3 minus negative 2. On the bottom, you're going to go 8 minus, put that negative sign behind that first number, 8 minus negative 5. What happens to minus a negative? What happens right here? Becomes a plus, that's right. So up top, what you've really got is negative 3 plus 2. What is negative 3 plus 2? Negative 1. And on the bottom, 8 minus negative 5 is really 8 plus 5, which is 13. But what's going to happen here is that we're going to get some people that go negative 3 minus 2, negative 5. 8 minus 5, 3. Guys, it's easy to do because you're seeing negative signs. You're thinking, oh, I got to subtract. There's a negative sign. Yeah, negative 3 minus 2, I got it. It's negative 3 minus negative 2. It's 8 minus negative 5. When you write that first number, put the minus sign down immediately, then bring in your next number. You need to be really careful when there are negative values involved, or else we're going to have a lot of sign mistakes. And those answers are typically waiting on you. Negative 1 over 13. That means for every y value that we go down 1, the x values go to the right 13. Guys, that's a pretty flat line. Down 1, right 13. Down 1, right 13. That would be a staircase that's not very steep. When your rise number is pretty small and your run number is pretty large, pretty flat. But that's that relationship between y and x. For every one y value this thing moves down, it moves 13 across to the right. Okay? Guys, if they give you the picture of a line, or they give you two ordered pairs, and they say, please go find the slope, it's a gimme. We have to get that right. We have to look at that and go, thank goodness they gave me that. I can get that. I'm getting that 100% all the time. Okay? Because there's plenty more they're gonna try to get you on as far as other concepts. But guys, if you just have to find slope from the picture of a line or from two ordered pairs of numbers, we got to get it. Got to see it as a gift.
Should have taught this before the SAT.
So, but slope is fundamental. Okay, these are fundamental concepts with slope, slope-intercept form, identifying slope, calculating slope. These are things we've got to be able to do. Okay. All right. Any questions?